Hi, and welcome to this video on lesson 4.5. Now we're factoring expressions. Okay, so on page 213, you'll see solve and discuss it. And it's talking about Tasha is packing gift bags that include the same items. She has 72 glow sticks and 36 markers and 24 bottles of bubbles. She believes that she can pack no more than 6 bags using all of her supplies. Do you agree or disagree? Well, let's say she has 6 bags, right? So she's going to pack, she's going to pack 6 bags. 1, 2, 3, 4, 5, and 6. And I'm assuming she's not going to make one bag that is all glue sticks and one bag that's all markers. What she wants to do is she wants to put the same items in each bag. So each bag has some glow sticks. I keep saying glue sticks, but they're glow sticks. Some glow sticks, some markers, and some bubbles. Now, what I want you to think about is what would be the way for her to be able to pack as many bags as possible and still have the same number of each. So why don't you pause this video and try this problem on your own. Okay, so you're back. So let's say I stick with this 6. It means I would take these glow sticks, these 72 glow sticks, and I'm going to divide them into 6 bags. So that each bag, right, so our glow sticks, each bag would have to have, or we can multiply by 1/6, right? Do it the way we did it before. Times 1/6 times 1/6, and we would get 12. Get 12 sticks, 12 glow sticks in each of these bags. And then if I do the same thing with the markers, say I have 36 markers in 6 bags, well then how many markers per bag? So I would multiply it by 1/6 again. I would get 6 markers in a bag. And then I would have 24 bubbles, right? 24 bubbles in 6 bags. Then how many bubbles in one bag? Times 1/6 times 1/6. I have 4 bubbles in each bag. So we would have, in each of these bags, we'd have 12 glow sticks, 6 markers, and 4 bubbles. But I noticed that all of those are even. And I have 4 bubbles in each of these bags. So could I take this and say, well, let's just take all of these bubbles and put them in a separate bag and make 4 bags from this one bag? Well, the problem with that is when I go to share the markers, I would have 1, 2, 3, 4, and then 5, 6. Well, I can't cut the markers in half, so I wouldn't be able to I would have like 1.5 markers in each bag, and I can't do that. So it looks like I can't make 4 bags out of each bag, but I could divide all of these in half and say, well, divide this by 2, divide this by 2, divide this by 2. I could actually take this bag and make it 2 identical bags with 6 glow sticks, 3 markers, and 2 bubbles. So then, and then over here, like 6 glow sticks and 3 markers and 2 bubbles. So that means I would have how many total, so if I took each of these bags and broke them up into 2 bags, I would have how many total bags? Well, rather than only 6, she could actually make a total of 12 bags. So what this means is I can take I'm going to erase this. I should actually divide all of these things not by 6, but instead divide them by 12. So there you go. And then that would give us by dividing by 12. So in this situation, this 12 is called this 12 that we found, this 12 bags we can make. This is called our greatest common factor. The greatest common factor of 72, 36, and 24 is 12, because that is the biggest number that goes into each of those numbers evenly. We can't have half a marker. So there you have it, 12 bags, the GCF. Okay, so where are we headed? I mean, with that problem, maybe you're not really sure what's going on. But let's first talk about opposite operations or inverse operations. We just learned about expanding expressions. So if you have a number on the outside of the parentheses, then you are to multiply each of the terms inside the parentheses by that number. So 10 times 2x would be 20x, because I just multiply the coefficients. And 10 times 9 would be 90, and I keep the subtraction between them. And we learned that even when you have a negative, that we can still distribute that. So we do negative 3 times 4, and negative, change subtract to add, and the second number to its opposite. So negative 3 times 4, negative 3 times negative 2x, and negative 3 times the invisible 1y. So I would multiply each of those terms. So negative 3 times 4 is negative 12, plus negative 3 times that coefficient of negative 2 is 6x, plus negative 3 times the invisible 1 is negative 3y. So I would have negative 12 plus 6x minus 3y. And so that's what we learned recently. Okay, so try to hold on to that information. Anything that we do in math, we have to be able to undo. So we can expand. Factoring is the thing we're going to learn today, and that's the undoing of expanding. It's undoing this multiplication and putting it back to what it was. Okay, so to factor an expression that has been expanded, what you want to do is think back to what it used to be before it looked this way. So it used to be there was parentheses, and there was a term here and a term here, and because this is an addition problem, I'm going to put a plus here. And then there was a number on the outside of the parentheses, and someone multiplied the number here by this number here and by this term here, and then ended up with 2x plus 6. Well, in order to get 2x, I would have to multiply 2 times x, or x times 2. Well, if this was x here, that would mean I would do x times 2 and x times whatever this is, which would give me an x in both of these terms. And I don't have an x in both those terms. So I know that means that x was not the thing on the outside. It must have been the 2. So I'm going to put, a 2 here and an x here. So 2 times x is 2x. All right, well, let me try this. Well, what happens when I put the 6 here then? The 6 from over here. Let's expand this. 2 times x is 2x, and then 2 times 6 is 12. But this isn't 12, it says 6. Well, that means that this wasn't 6 here. 6 is the result when we multiply it by 2. So what did we multiply by 2 to result in 6? Well, 2 times 3 is 6. So this had to be a 3. So now 2 times x is 2x, and 2 times 3 is 6. So now I've had it. So what I can notice is that both of these terms have 2 as their factor, and 2 is their greatest common factor. So there it is again, the greatest common factor. So then let's look at our next problem. We're trying to find the greatest common factor of the two terms, because it used to be there were two terms in these parentheses, this minus, because there's a minus there, something else. And then there was a number out here that was being multiplied by both of them. And I know it's a number, not an n, because they don't both have n's in their term. So something, but I know this had to be an n. There had to be an n here. That's how the n got to the front there. So something times something is 16. Let's see. Let's list all the factors of 16 as pairs. 1 times 16, 2 times 8, 4 times 4, and that looks like there's all there is, okay? So now let's list all the factors, because we're looking for common factors. Let's list all the factors of 24. 1 times 24, 2 times 12. Oh, look at that. We have something in common, 2 and 2. Let's keep going though. 3 times 8 and 4 times 6. Okay, well, I see that they have 2 in common, right? And they have a 4 in common. So maybe the greatest common factor is 4. If I look closely at all my factors, I also see another factor that's bigger than 4, and that's 8. See, 8 times 2 is 16, and 8 times 3 is 24. So 8 is the greatest common factor for both 16 and 24. So watch, 8 times 2 is 16. 8 times 2 is 16n. And 8 times 3 is 24. So 8 times 3 is 24. So let's do that again. 8 times 2n is 16n. 8 times 3 is 24. And I put a subtract in the middle. So there it is. I have factored this and accidentally did it in LSU colors, so sorry about that. Anyway, but I factored this expression, and now by finding the greatest common factor, which is 8. And here are the answers again from the previous problem in case it was hard for you to read. So there, that's called factoring. So the example in your book starts with example 1. They have this word problem, and the word problem honestly makes no sense to me whatsoever. So what they want to show you is if this rectangle here was 3 times x is the area, and this was 3 times 4 is the area, which is 12, then I could say that the other way to find the area is to say, well, this side here is really x plus 4 if I add it together, and this side is 3. So 3 times x plus 4 would be another way to find the area. So this is called the factored form, and this is called the expanded form. And that's what they want to show you. So the GCF is 3. So let's look at another example. In your book, in the Try It, they have a problem for you to try. And what they want you to notice is you're going to factor it. So you're looking to see, okay, what did I multiply x by to get 4x? I must have multiplied it by 4, right? Because 4 times x is 4x. Well, if this is 4, then this number in here is not 20. 4 times what is 20? 5. So there it is, it's factored. Because 4 times x is 4x, and 4 times 5 is 20. And I would always recommend you going back and expanding it to make sure you have the right answer. But voila, that's it. So then they try to use area to show negative coefficients, and that makes even less sense. But what they want you to know is you can even factor things when they're negative, but you have two choices. I can either say here that negative 2x is negative 2 times x, or it's 2 times a negative x. And if I do that and I'm over here at the 6, I have to be very careful, because if I choose negative 2 as my common factor, then that means I should look at this as negative 6, because negative 2 times 3 would be negative 6. So now I can factor out, and that goes with this one. I can factor out a negative 2, and I would have x plus 3 inside the parentheses. Or the other thing I can do is I can factor it and look at this as, maybe that this is, 2, and then the negative goes with the x times negative x. And then over here, minus 2 times, 2 times 3 is 6. So now 2 is my greatest common factor. So that's what it's showing here. If I take the 2 out, then I would be left with negative x and minus 3. But both of those are actually okay. They're both correct, whether you put the negative or not. We tend to like it for you to use the negative as the factor so that you have the terms inside the parentheses don't have all the negatives. But either way, it's actually correct. So there's two different ways of factoring negative 4x minus 28. Why don't you pause and try now? Okay, I'm back. So here's the thing. I can either look at this, let's rearrange this. So I have negative 4x plus negative 28. And I can either look at this as negative 4 times x. And then I would say, okay, so I need my common factor to be negative 4 because it can't be x. So negative 4 times what is negative 28? Well, negative 4 times 7 is negative 28 because negative times a positive is a negative. So then I've chosen to make negative 4 my common factor. So that comes out negative 4. And what's left? X plus 7. So that's one way to factor this. The other way is to say, okay, so negative 4x minus 28. Well, that's really a 4 times negative x. And then 28 is, or plus negative 28, then I would have 4 times what? Well, times negative 7. So now my common factor is 4, which is positive. So I have 4 here and 4 here. So I would have 4 on the outside, and the parentheses would be a negative x plus negative 7. Negative x plus negative 7 is really minus 7. So these are the two possible ways. So notice that in this way, the negative is with the 4 and everything in the parentheses would end up being positive. But here, the 4 is positive, so everything in the parentheses ends up being negative. So you're going to see that it ends up flip-flopping depending on the way that you decide to factor it. Now let's say we have to factor 3 terms. Okay, so when you're factoring 3 terms, we need to look and see what their common factor is. And there's actually kind of like a trick to finding the GCF. And so there's this L method. All right, and what I'm going to do is write each term. 6x minus, so it's plus negative 18, and then plus negative 12y, okay? And I'm going to think about a number that goes into 6, 18, and 12. Let's say 2, okay? 2 goes in all of them. So I'm going to divide, or think 2 times what is 6? 2 times 3, and don't forget the x is 6. And then 2 times what is negative 18? Well, 2 times negative 9 is negative 18. And 2 times what is negative 12? 2 times negative 6, y. And I got to bring the y along because it's back there. So now I found, and now I'm going to look 3, 6, and 9. Well, common factor for 3, 6, and 9 is 3. So 3 divided by 3 is the invisible 1, x. Negative 9 divided by 3 is negative 3. So I should be able to multiply back. Like 3 times x is 3x. 3 times negative 3 is negative 9. And then 3 times what is negative 6? Negative 2y. So is there a common factor between the invisible 1, negative 2, and negative 3? Nope. So I'm going to bring this straight down. X minus 3 minus 2y. That's what goes in parentheses. And then what goes on the outside? Well, now what am I going to do with these two numbers? Do I pick one? No. Do I add them and get 5? Well, that wouldn't work because if I put a 5 here, 5 times x is not 6. So what do I do with this 2 and 3? I'm going to multiply them. I'm going to multiply 2 times 3 and get 6. Watch. 6 times x is 6x. 6 times 3 is 18. 6 times 2 is 12. So that's what you do with this number here. You can multiply them, and that's going to give you the GCF. So there you go, the GCF. So that means that we have now factored it, and that's a way of factoring things if you have lots of numbers. The other way to do this would be to list the factors, and then to list them out like you learned in 6th grade, and then just find the one that's the biggest, and that would be the GCF. So you could try it that way too if you didn't like the method I just showed you. So then let's just try number 4, and let's find the greatest common factor of these terms. So I'm going to set up my little thing here. I have negative 12x, and then positive 24, and then plus negative 18y. So I think about a number that goes into 12, 24, and 18. I think of 2. So I'm going to divide all of these by 2. Negative 6x, 24 divided by 2 is 12, negative 18 divided by 2 is negative 9y. And then I look, see, 6, 9, 12. Well, 3 goes into all of those, so I'm going to put 3 here. So negative 6 divided by 3 is negative 2. 12 divided by 3 is 4. And negative 9 divided by 3 is negative 3y. Now I notice that 2 and 4 have a common factor of 2, so I might think, oh, I can do 2. But over here I have a 3. So, so 2 doesn't go into 3. So it means this is it. We found it. Negative 2x plus 4 minus 3y. Those terms don't have a common factor anymore. So their greatest common factor is 2 times 3, which is 6. I can check it. 6 times negative 2 is negative 12. 6 times 4 is 24. And 6 times negative 3 is negative 18. So we did it. We found the GCF. So Susan, on page 216, number 2, Susan incorrectly factored the expression below. She had 12a and negative 15b and positive 6. And so she factored out a 3. Well, let's multiply back and see if this works. 3 times 4a is 12a. It looks so good so far. 3 times 5 is 15b. Well, 15, right? And 3 times 3 is, that would be 9, not 6. So this right here, that should actually be a 2, because 3 times 2 is 6. So that's her one mistake. The other mistake she made was what? Well, remember I said 3 times 5 is 15, but isn't it supposed to be negative 15? So this should have been a negative 5. So to factor it correctly, it would be 3 still, but 4a minus 5b, so that I get that negative 15, plus positive 2 to get 6. And there you go. There's number 2 on page 216. Okay, so hopefully you've learned something then about factoring and how to find the GCF, the greatest common factor. If worst case scenario, just list them. But thanks for watching.